So the next step, on the previous lesson, or on the previous, when we first introduced the Pyro solver, we created everything separate. We had a geometry container for the smoke vortex, we had the DOP network outside, but we can actually do everything inside the one geometry container. So let's do that for now. And I'm going to create the DOP network inside, and I'm going to connect this to the first input. There is an advantage to that, is that you can actually refer to the first input of the DOP network easily in some cases. So let's do that. I'll create I'll say Pyro Sim. Let's dive inside and create the usual elements that we need. We need the smoke object. We need the Pyro solver. And we'll need the volume source. And here in the volume source, you can say that the input, instead of a SOP, you can use the first context geometry. Let's connect everything together. And here on the smoke object, let's grab the division size, copy parameter, go outside, and here on the volume rasterize, base relative references. Okay, let's put this to a more reasonable value, 0.04, bit frame 1. So we definitely need to make this bigger. We already know that the size will usually be, let's copy the y-axis, copy parameter, base relative references here, and just divided by 2, so it's always on the ground. If you want to have an idea of the size of the element here, you can do the same trick. So let's create a static object, and let's merge it into our simulation. And I'm just going to choose here on the static object, let's just choose the mountain, for instance, just so we have an idea of what's happening. And here in the smoke object, let's make this 4, should be enough. And here 4, probably not enough, maybe 4.5. And here maybe 4 as well, 4.5. Yeah. One thing we didn't do before is you have this option of using close boundaries, and we're going to turn this on. This just means that the smoke, whatever is happening on the simulation, when it reaches the edge of the bounding box, instead of being cut off, it's just going to hit that limit of the bounding box as if it were a solid object. So we don't want this on except for the ground. I want it to kind of the smoke to be able to collide with the ground, or at least give us that illusion. And I think we're good. We don't need this anymore, so we can just delete it. Here on the volume source, we have that, but we need to initialize it, so we need to switch this to source smoke. And here we're going to make use of these 3 operations. We have density, temperature, and we're going to be grabbing the velocity as well. On the Pyro solver, I'm going to go ahead and disable the enable combustion, and on the advanced, I'm going to turn on OpenCL. Let's go back to our camera. We should also have some lighting, but let's just hit play and see what happens. There it is, our vortex. Stop. And I'm just going to make sure, go outside and create some kind of lighting. I'm going to use the skylight again. And here in the smoke vortex, if you turn this on, it's not going to show you anything, but we can go ahead and already create the DOP import fields. Okay, this is the node that we were using to grab the information coming out of the PyroSim from the network, from the DOP network. So we can just put the DOP network here. On the DOP node, we're gonna say it's the smoke object we just created. The name is smoke object 1. This does work with wildcards, so if you just want to do smoke object star, it's going to work as well. Let's hit back, and now you can choose the preset. Don't forget to choose a preset. I'm not going to be grabbing anything else except for the density, for now at least. There it is, and now we can see it with shadows and everything. Let's just turn this on, and I'm going to go outside to the sunlight and give it a try here on the controls of the skylight. Allow you to adjust the rotation here, rotate angles, and maybe something more. Let's try some rotation here. I'm going to put it coming from the back. There, something like this. It's a bit more ominous, I guess. Okay, so the ring is being lit from that angle. You can even make it lower, 30. Yeah, this should be give us an interesting shape. Okay, now that we have this, I'm actually gonna go out of the camera just to show you something, because yeah, from this angle we'll have a better idea of what's happening in 3D, and then we'll go back to the camera. So going back to the simulation, one thing I want to change is I'm going to make use of the possibility that we have of changing the buoyancy direction. I want the smoke, instead of being going up because of the high temperature, I actually want the buoyancy, redirect the buoyancy towards this way, towards the camera. That way it's going to make more of a tunnel effect. So here, let's change this to 1 on the z-axis. I'm going to increase the buoyancy a bit. And what else? Here, I'm going to lower the temperature diffusion slightly, just as a way of keeping a bit more detail, and maybe increase the cooling rate. So what this should do is increase the speed at which the temperature is going down, and that means that even though it starts going fast, it starts lifting on this direction fast, it's going to slow down fast as well. And for now, let's keep the dissipation high, 0.6. I want to have the dissipation having an effect, a strong effect. So we need to remember that this volume source is adding to the temperature constantly, always adding to the temperature. So if we establish that the dissipation is going to use as a control range a value of 0 to 1, it might not be enough. So I'm just going to put this to 2. So this means that dissipation is going to be very high when the temperature is very low, and it's going to be very low when the temperature is at high values. Okay, so it's not going to dissipate when it's still very warm, which this curve makes total sense, but I just want to make sure that I consider the whole range of temperature that we have here, which is going to go way beyond 1, at least near the source. What else? And for now, let's just keep it like this, and let's see how much the buoyancy is working. Hit play. We should see it coming this way. Okay, it's looking nice. Maybe I'm killing it a bit too fast. We should also make use of the gas resize. Remember, we should give it a tracking object just so it keeps the simulation with a container at least the size of the source. Going to give us faster feedbacks as well. Okay, it's not as interesting to have a look at the simulation without the lighting, but what we can do is we can go to the object level and we can pin this view, and that way, even though we're inside, we're actually seeing it with this level of detail coming from the lights. Let's see this. And as you can see, it's actually hitting the ground as well.